Welcome to Angular Coding with ChatGPT 3.5 and 4.0. Let's recall what application we have coded so far, thanks to ChatGPT 3.5. It is a three-tier application consisting of a front-end layer made by Angular materials, a business layer in a web API structure created in .NET Core C#, and a persistent layer with a database SQLite. So how does that look in real life? Here you see the application, where the current main menu is the SOX menu with its submenus displayed as material menu cards. And how does that look in code? At first we see the home component of the Angular client, which uses the menu service to render the submenu items as material menu cards. The data coming from the menu service is injected into the HTML part of the home component. But nothing happens so far when clicking on the mat card. There must be action when clicking on it. Who better than ChatGPT could write the user story? A user story where the actor manages the risk management. I want now implement the submenu risk management of the main menu SOX with the given architecture. Angular as client, .NET Core as web API, and a SQLite database. As you know, each software cycle starts with writing a good user story. Could you write a good one for me?
Sure. Here's a user story for implementing the risk management submenu under the SOX main menu. As a compliance officer, I want to be able to access the risk management submenu under the SOX main menu so that I can easily view and manage potential threats to the organization's objectives. When I click on the Risk Management submenu, I should be taken to a page that displays a list of risks currently identified, along with their potential impact and likelihood. I should be able to sort and filter the list, as well as view additional details about each risk by clicking on it. Additionally, I should be able to create new risks, update existing risks, and delete risks as necessary. Any changes I make should be saved to the database and reflected in the list immediately.
So ChatGPT, are you ready for implementing the SOX risk management?
Absolutely. I'd be happy to assist you with this. I'll provide you with code snippets for each of the necessary components. Let's break down the user story into actionable parts. 1. UI component, an Angular component, or components, for the risk management submenu that displays a list of risks, along with their potential impact and likelihood. Provides the ability to sort and filter the list, allows viewing additional details about each risk by clicking on it, enables creating new risks, updating existing risks, and deleting risks. 2. Web API, a .NET Core API, that retrieves all risks, retrieves a specific risk, creates a new risk, updates an existing risk, deletes a risk. 3. Database, SQLite database operations that handle the CRUD, create, read, update, delete, operations above. We'll start with the .NET Core API and SQLite database operations, since the Angular component will depend on these. Once we've defined the API, we'll move on to the Angular component. Does that sound good to you?
Yes, and I can tell you I have already managed the web API and the database part. I send you now in a zip file the relevant files of the web API and Angular client. Please unzip the file and analyze the code files.
Great. I see several files that may be relevant to our task. Let's focus on the following. Risk Controller. DS. This is likely the .NET Core API controller for risk management. Risk DTO CS. This is likely the data transfer object, DTO, used for risks. SOX risk management.component. HTML. This is the Angular HTML template for the risk management submenu. SOX risk management.component, CSS. This is the CSS for the risk management submenu. SOX risk management.component, TS. This is the TypeScript code for the risk management submenu. Data service, TS. This is likely the Angular service that communicates with the .NET Core API. Edit popup dialog.component, TS. Edit popup dialog.component, HTML. Edit popup dialog.component, CSS. These are likely the components used for creating, updating, and deleting risks. I'll analyze these files to understand the existing code structure.
But how can it analyze the files from the input zip? To analyze the code, ChatGPT 4.0 uses a tool called Code Interpreter that can receive in one chat, one file. If you want to analyze more files and do it in one step, you should zip it. And by clicking on this button, you can see what happens behind the scene. The input zip file is extracted and the content of the zip is stored in extract_path. And what happens after the zip? At this stage, ChatGPT has already unzipped the input file and is now reading the content of each file and storing it in a dictionary with the name file _contents. After that has been managed, the file information is passed to the actual ChatGPT engine that then tries to understand the answer of the code interpreter so that it can come up with code recommendations in form of code snippets. Aww. So let's ChatGPT do the work and we will earn the fame?
Sure, let's make these adjustments. Here's a revised version of your SOX risk management component, TS. Here, the risk model should have properties that match those in your risk DTOZES file. For instance, if your risk DTOCS has properties like ID, name, description, date created, impact, and likelihood, then your risk model should also have these properties. Also, the column schema array has been defined to match the properties in your risk model. This array is often used in Angular material tables to define which columns to display and how to display them. In your HTML template, you will use this array to generate the table columns dynamically. Please adapt this code snippet according to your needs and let me know if you need further assistance.
Yes, I really need more than stubs.
All right, let's continue by implementing the methods of SOX risk management component. Please adjust these methods based on your actual requirements and application structure. The ngOnInit method is called once the component is initialized, and it sets the risks $observable to the list of all risks. The nagAfterViewInit method is called after the component's view, and its child views have been initialized. It sets the data source and paginator of the table to the risks $observable and the paginator view child, respectively. The onAdd, onUpdate, and onDelete methods are triggered when the user tries to add, update, or delete a risk, respectively. They open the appropriate dialog, handle the user's input, and send the appropriate request to the risks service. Again, please adjust these methods based on your actual requirements and application structure. If you need further assistance with this, I'd be happy to help.
So let's see whether it's working. And yes, the list of risks is appearing. We can see that records having a high impact get a light red background color. And if we want to update a record, we press the edit button of that specific row we would like to update, and a pop-up dialog will appear allowing to make the changes. We can also filter the list. I just enter, for example, risk, but as I see, that is not a good example for demonstrating the filter functionality. Let's take negative, and here we can see better the filter impact. The filter applies, by the way, to each column. By changing the Boolean attribute, edit pop-up in the Angular component SOX risk management, we can change the style of the edit row mechanism to inline editing. Let's look under the hood. We are here in the risk controller of the .NET Core web server, and I am setting the breakpoints. Let's switch now to the SOX risk management component in Angular. I'm going to set the breakpoints here in the ng-ownit event, where all important objects of the risk component are initialized. In our case, it's mainly the risk list, which is handled by an observer object which triggers the HTTP call to the web API and catches the result arriving asynchronously. So we are starting our round trip by calling the debugger, clicking then on the SOX risk management map card, and we'll end up in the debugger. There is on the one hand called in ng on init the observable called data source, which on the one hand calls the web API of the risk service and receives the API answer in the observable subscription part, which receives the response of the API asynchronously. Here we see the HTTP call of the URL API risks from the Angular client, and immediately afterward we are in the debugger of the web server catching the HTTP request. The web server receives its data from the database, and we can check the result inside the web API's debugger. Then we continue, and the web server sends the data answering Angular's request back to the client. On the Angular client side, the server response is fetched and then afterward injected into the HTML template of the SOX risk management. So the SOX risk list can be retrieved, updated, deleted, filtered, and sorted. All requirements of the user story are fulfilled. But if you think coding is now done by machines alone, you are wrong. You still need to have a good overview about your software architecture and a comprehensive understanding of the underlying user story. And most important, you must communicate in an appropriate, clear manner, else artificial intelligence cannot help you like natural intelligence either.
Oh, these humans, they still think they are needed.